Hey everyone, welcome back again to H.S.P World of Chemistry. So here is the mind map for complete class 11th hydrocarbon chemistry. You will see that almost all the reactions are there, right? So should we start? I will tell you how to just put it in a hippocampus, how to get best out of this, right? Now, my dear students, you see, this is the whole mind map, east, west, north, south, whatever the dimensions. So, just see from where I will start. My target is methane. You see, something is moving. Can you see? Methane. I will start from here. So, zoom in. You see, this is your methane, and I will let you know. I made the smallest mind map for myself in class 11, that is 1993. I was a kid only, right? So let's see. I'm going to share it. How will you convert a methane to methyl chloride? Can you see? Methane to methyl chloride. So you have to do chlorination and sunlight. Now, my dear students, let me tell you one more thing, that either you can do reaction of Cl2 with sunlight. This is known as photochemical reaction. Photochemically, we are doing this reaction. So, this is photochemical reaction. Now, my dear students, in the examination, examiner can give you the same reaction, that is thermally. What? Thermally. What is that thermally? That Cl2, same Cl2, they can give you Cl2 and temperature. For example, 200 to 500 degrees Celsius. So, up to 500 Celsius degree temperature they can give you, and we will call it thermally. So, either thermally or photochemically, the product will remain same. So, is this point clear to all of you? So, this is known as free radical substitution reaction. You have to keep it in your brain. Such type of reaction is known as free radical substitution reaction, FRSR. FRSR. Everyone say along with me what I said. FRSR. Just say free radical substitution reaction. So, whenever the examiner is giving sunlight, diffuse sunlight, H nu, whatever in place of sunlight, or he is giving H nu, or he has given diffuse sunlight, that means that's the indication for FRSR and methyl chloride we got. Now, see, methyl chloride, sodium dry ether. You see the sodium dry ether, this reaction's name is Wurtz reaction. It's not Wurtz Khalifa, it's Wurtz reaction. It's the ascend of series. Doubling of the compound will be done. So, methyl chloride will give you ethane, ethyl chloride will give you butane, isopropyl chloride will give you 2,3-dimethyl butane. So, like that. Now, my dear students, we got methane. Now, you see, on the left hand side something is given over there, this, but I am not going to tell you this thing, right? First I will complete, my aim is to complete the round circle. From where we have started, we have to reach over there. This is the way you have to complete your circle. You have to do your revision. Okay, now see, methane, once again I have done free radical substitution reaction, FRSR. You see FRSR, I got methyl chloride. So, sorry, yeah, FRSR I have done. So, I got ethyl chloride, ethyl chloride. So, free radical substitution reaction. Now, if I do the reaction with KOH alcoholic and heat, this is known as elimination reaction, that is your E2, dehydrohalogenation. Dehydrohalogenation. Now, you see, by chance they have written some compound which is having triple bond and CS2. So, this is wrong. So, let me write down, there should not be triple bond, there should be double bond. I hope it is very much clear to all of you. One bond was extra by chance. Okay, now this is your ethylene. Now one arrow is coming from that side. Don't focus on that arrow right now. Our focus is to complete our round circle. So see, ethene is reacting with Br2. This is known as electrophilic addition reaction, halogenation. So you got ethylene bromide. It's your vicinal halide. What? It's your vicinal halide. Okay, the name is ethylene bromide. Now, if you react this ethylene bromide with excess of NaNH2, so the reaction will actually reach up to disodium acetylide. But if I react this ethylene bromide with NaNH2, and that excess part is, if I say 2 equivalent, with the 2 equivalent, then my reaction will get stopped at acetylene and I will get acetylene. Now see, one arrow is coming from the left hand side, so right now I am not going to deal with that. That should be the diversion. We won't be able to keep the things in our brain. Now acetylene on reaction with water, just apply Markovnikov's rule, that give one oxygen to one carbon and two hydrogens to one carbon. So CH3 CHO. Actually, now once again, one extra bond is there. So let me remove that bond. Now see, CH3 CHO means double bond, right? CH3 CHO, and that's why I have told you if any error is there, so I will let you know during the reaction. CH3CHO is double bond, acetaldehyde. Now acetaldehyde, actually this OMDM reaction was oxymercuration demercuration reaction. Is first water will get add up, you will get enol, and that enol will convert into keto form, because enol is not stable. But directly you can do reaction, and that is valid because this reaction will take place without any rearrangement. Now CH3CHO, CH3CHO is oxidation with SOA, strong oxidizing agent. It will convert into acid. We got acetic acid, and now acetic acid on reaction with NaOH excess and calcium oxide, you know very well, soda lime reaction or decarboxylation reaction, or the lab method preparation and of alkane, you got methane. You see, first of all, the scene, you just focus on this round circle. I have just gone with this round circle, and that is your target. First complete this round circle. If you really want to get marks in your Neet or any other examination, always try to complete this circle. This was the first mind map I prepared for myself, and it really helped me a lot. At that time I was doing conversion faster than even my teacher. Really, you won't believe, right? Anyways, once the circle got completed, then we will get inside of the circle and then the periphery. Okay, now see, inside of the circle says that this ethane, if I react it with O2, copper and heat, I will get ethyl alcohol. What I will get? My target is ethyl alcohol. I will get ethyl alcohol. And if I do the reaction of ethyl chloride with aqueous KOH, I will get ethyl alcohol. Now see, ethyl chloride is reacting with alcoholic KOH, it gives ethene, elimination. But once it is going to react with aqueous KOH, substitution. So remember that alcoholic KOH and heat will do elimination, aqueous KOH will do substitution. Now I got ethyl alcohol. Now from ethyl alcohol, if I want to convert ethyl alcohol into ethene, so see what I will do. I will convert ethyl alcohol into ethene if I do this reaction. Reaction with concentrated H2SO4 and 443 Kelvin. Remember that this temperature is very, very important, because less temperature, substitution will take place, and that will say diethyl ether. See, suppose if I have reacted this ethyl alcohol with the concentrated sulfuric acid H2SO4, and the temperature, if I have maintained 413 Kelvin, 413 Kelvin, then this is known as Williamson's continuous esterification, and I would have got diethyl ether. It's given in your NCERT, right? So now you see, focus on this reaction, that this is Colway's electrolysis. So if you do Colway's electrolysis, just double this compound CH3COOK. Now double it, let me write down so that you can get proper notes. So if I double this compound CH3 COOK, I'm going to give you short trick for this. Just see at this place, this will form ethane at anode and 2 moles of carbon dioxide also at anode. So what I will get at anode, if I do Colway's electrolysis, if I provide current, what I will get at anode? I will get ethane, 1 mole of ethane I will get at anode, 2 moles of carbon dioxide I will get at anode, that means 3 moles of gas I have got at anode. I got at anode 3 moles of gas, and at cathode, because aqueous is there, I will get hydrogen gas at the cathode, and in the solution I will get KOH, 2 moles of KOH. That's why during this reaction pH keeps on increasing. pH always keeps on increasing during the reaction. Now see, my dear students, there was something, as I have told you at that time, if you do its Colway's electrolysis, then you will get ethene. See how you will get ethene? Once again the same fundamental thing, you break it from here, this will form ethene, this will form ethene at anode, 2 moles of carbon dioxide at anode and 1 mole of hydrogen gas at cathode, and KOH in the solution. So now how to form alkyne? That is always Colway's electrolysis. So see, Colway's electrolysis is used for the preparation of alkane, alkyne. Once again, if you provide current, so see, something is written over here, let me first of all rub it. It's CH, actually it's wrong, it should be, let me write down, CHCOOK. Its name is and double bond will be here, double bond. Its name is potassium malate. What is the name, kids? Potassium malate. The silver should not be there, so let me rub it, no silver, and actually it's this compound's name is potassium malate, potassium malate, potassium malate. Now the same funda, if you provide current, this bond will break from here, and acetylene you will get at anode, 2 moles of carbon dioxide you will get at anode, KOH in the solution, and hydrogen gas at cathode. So this round circle is completed, only one thing is left, this methyl chloride. If you provide hydrogen and zinc, so methyl chloride means Rx will convert into RH, hydrocarbons. So done and dusted the first part. First part we have completed. Now we are going towards the second part, and that is benzene, right? Let's see. Bridge, same, the acetylene are hero right now. Acetylene on reaction with red hot copper tube, the polymerization will take place. This polymerization, just focus over here, this on treatment with red hot copper tube or iron tube at 500 to 600 degrees Celsius will give you benzene. This is known as polymerization reaction, right? Now let's see the benzene. The most important reaction of benzene is this one. This one. Just see, and this compound is having 6 chlorines. Sir, 6 chlorines. I too can only say see 4. No, my dear friend, just check it out. 4, 5. Oh, even I can see only 5. So, see kids, let me write down 6 chlorines should be there. 6 chlorines means your 6 chlorines, just see, 1, 2, 3, and this is missing, 4, 5 and 6. 6 chlorine, 6 hydrogen and 6 carbon. Triple six, 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 six. Remember that its name is triple six. Its name is BHC, benzene hexachloride. Remember that this is very, its name is having BHC, benzene hexachloride, but there is no benzene. Just see, it is cyclohexane. Always remember that it's cyclohexane. It The examiner will definitely give this question. This time examiner will make tough. This time also examiner has given that on reaction with Cl2 sunlight or Cl2 dark. That was simple question because in both there are 6 chlorines, but here 6 chlorines, 6 hydrogen and 6 carbon. BHC, and remember that this is BHC, benzene hexachloride, but there is no benzene. So examiner can give assertion and reasoning. So take care, there is no benzene, and simply they are giving BHC is aromatic. You will say wow, and it follows Huckel's rule and planarity rule. You will say yeah, of course. You will get trapped. So take care, it's not aromatic. Let me write down, this compound is not aromatic at all. Not aromatic. Not aromatic. Once I was teaching this in my class. At that time I was in very big coaching, and one boy made one code BHC. In Hindi it is Bina hole ke. There is no hole. I said okay, good. Now its name is lindane also. Lindane. Remember that. Lindane. There is gas indane, but it is lindane. This is also its name. One more name, Gamaxine powder. Farmers are using it as Gamaxine powder, and it is having very good use as insecticide. Insecticide. But remember, it's not aromatic. Now see, one more compound where people generally gets confused. See, if you react this, once again there is some misprinting here. It is Cl2 and FeCl3, 3 times Cl2. It's 3 times Cl2, 3 times Cl2. Now you see 3 times Cl2. Now if you see, it is having benzene. If you see, it is benzene. It is aromatic, and it is, I would like to say, it is C6Cl6. There is no hydrogen. 6 hydrogens, they have gone with what? They have gone with, now if I say 3 times Cl2, so it's not working. I have to write 6 Cl2 because 6 HCl has to go. So how many Cl should be required? Atoms of Cl must be 6 and 6, 12. So I should write here 6Cl2. What should I write here? 6Cl2. Remember that. I should write here 6Cl2, not 3Cl2, because 6HCl has to eliminate out, right? So I will write here what? Tell me, what should I write here, kids? Everyone just do let me know. 6Cl2, 6Cl2, and it is substitution reaction. This is going to be substitution reaction. Which substitution? Electrophilic substitution reaction, that H are eliminating out and Cl are taking its place. And that reaction was, just see, this was which one? This was your addition reaction. The Cl got added in place of double bond. So I will say free radical addition reaction. This was your free radical addition reaction. My dear students, remember that it is free radical addition reaction. In place of double bond, chlorine got added, but it is your ESR, electrophilic substitution reaction. Hydrogen got replaced by chlorine. Still benzene is there. Benzene has not lost its aromaticity, and its name is hexachlorobenzene. What is its name? Its name is hexachlorobenzene. Hexachlorobenzene. Remember that it is hexachlorobenzene. Now, my dear students, got it? It's hexachlorobenzene. That was benzene hexachloride. Now, halogenation we have done. Now it's the time for nitration. If you see written there, nitration. How will you carry out nitration, my dear students? For doing nitration, use concentrated HNO3 and concentrated H2SO4. Concentrated H2SO4. This is known as nitrating mixture. Concentrated HNO3 and concentrated H2SO4, both together they will produce nitronium ion NO2 plus. This is the actual attacking agent. Now sulfonation is reversible. Oleum, if you are using, very well reaction but reversible. Sulfur is not from second period, so this reaction will come back. Now Friedel-Crafts, alkylation and Friedel-Crafts acylation. If you want to do alkylation, there carbocation will get formed, and you know that this carbocation once formed, it will show 1,2 hydride shift, and isopropyl will attack on this, and you will get isopropyl benzene, my dear students. And you see, if you use acetyl chloride, that will attack on benzene, and this is Friedel-Crafts acylation. There will be no rearrangement because this CO plus is already stabilized by back bonding. So your compound will be acetophenone. This is known as acetophenone. Remember the name of this compound, acetophenone. So this is also, this part also got completed. So right now if you see the reaction, this part we have already completed in the first starting. Then we have completed this second part. It's looking like what will you say? It's looking like a tree having its branches coming down. Now only one extreme right part is left. Now see to the extreme right part, and it's going from your acetylene only. Just see, it's one river is going from acetylene, ding 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 ding, NaNH2, 2 moles of sodamide you will use. And so I will write down 2 equivalents of sodamide we have to use. Both sides sodium will attach, we will get disodium acetylide. What is the name of this compound, my dear students? It is disodium acetylide. What is the name of compound, kids? Do let me know. Disodium acetylide. Disodium acetylide. Disodium acetylide. Now the carbon is having negative charge, sodium is having positive charge, carbon is having negative and sodium is having positive. So methyl is del plus and chloride is del negative. NaCl will eliminate out. So 2 moles of methyl chloride are required, and in this way we will get compound but2 ion. 1, 2, 3, 4. It is but 2 ion, but 2 ion. Now, my dear students, if you use Lindelar's catalyst, upper side you see this is your Lindelar's catalyst H2PDC. H2PDC हेतु पड़ोसी कार्बन की. So you will get cis alkene. What will you get? You will get cis alkene. In place of H2PDC, they can give you H2PD, barium sulfate, charcoal, boiling xylene, quinoline. They are also Lindlar's catalysts. So let me write down. If by chance they are giving you H2, H2 PD, barium sulfate, charcoal, boiling xylene, quinoline. They are also talking about Lindlar's catalyst only. Just like to live a life, we need house, water, some money. These things are required, food and all. But some people are having big car, big bungalow, jet plane, that plane, this Ferrari, that car, Audi, BMW, number of things. If they are also there, then it's okay. Okay. So you will get cis alkene. But if they are using sodium, lithium, liquid ammonia, just see sodium, lithium, liquid ammonia, then your alkene will be trans. Remember that alkene will be trans. Trans alkene will be your product. So what I am saying, see this place, just focus on this place. When you are getting cis alkene, when you are getting trans alkene, the upper side cis alkene, the lower side trans alkene. Now, if we want to complete next part, that is stereospecific, stereoselective, regiospecific, heavy word. But let me make it very clear, very simple. For that, you have to remember one trick. Hey, trick, sim, come on, this trick. If you want to make your life easy, remember this trick. TAM, everyone say TAM, Tushar, Kar, Sesam. If you can't remember like this, you can say mat, go opposite mat, roast, race, MSc. Whatever the way you want to keep it in your brain, that's your choice. Kids' choice is yours. What way you want to carry it in your brain. Remember that T stands for trans, A for anti, and M for meso, and S for sin. Now, you have kept it in your brain. What does it mean? Just see to it. The meaning of this is whenever you see BR2, whatever the BR2 is going to do, it will always do anti. Now, what is anti? Don't right now, do not apply brain. I made one video. If really you want to know the in depth of this, you can watch that video. Okay, I have written over there. Okay, detailed analysis. But examiner is not going to ask. So just remember, whenever BR2 is getting added or eliminated, it will do anti. And Bayer's reagent will do syn. Bayer's reagent is 1% cold dilute alkaline KMnO4. Now, what is the meaning of it? Just see. Let me come back that whenever your alkene is trans and anti means Br2, then product will always be meso. To trans alkene, if anti addition is taking place, product will always be meso. And on trans alkene, if syn addition, that is Bayer's reagent, then the product will always be racemic. Now, if cis alkene and anti addition is taking place, product will always be racemic, and cis alkene syn addition is taking place, then product will always be meso, my dear students, right? Okay, now let's apply. If this much you have kept in your brain that Br2 always anti and Bayer's reagent is always syn, now let me start. You see that this alkene, oh, this is alkene, alkyne got converted into alkene, but still you see triple bond is there. A I made this chart memory map and I have given to my team just to make it in a good handwriting. So they have made it, their writing is so well, but actually they don't know what is the difference between triple bond and double bond, my dear students. So that's why I'm here to rectify it. You should get 100% correct thing. Now see, this alkene is your cis alkene. Okay, cis, C for cis. Now Br2, whatever Br2 is going to do, it will always do anti A anti. Now complete C C A, complete C A C A R R C A R. So your product is racemic mixture. That means these two are BR here, BR. You see they are mirror images of each other. That means they are enantiomeric pairs. Enantiomeric pairs. So the solution will be optically inactive. 50% of dextro and 50% of levo, enantiomeric pair, racemic mixture. Now if you see Bayer's reagent, that will do syn addition. Syn. So C, just see everyone. C S M meso CSM cis alkene syn addition meso product. So it's got completed. Now let's come back to this one, the trans alkene. This is trans alkene. Now trans alkene, the same reaction we are going to carry out. Br2 will always do anti addition. So if you see trans T anti A T A, complete T A. If you see T A, where I have written T A, T A TAM, meso. So product is meso. It is having chiral carbon, but along with chiral carbon, it is having plane of symmetry. Whenever two chiral carbons are there and still plane of symmetry is there, we will call it meso. And meso is optically inactive. Optically inactive. It is optical isomer, but still optically inactive because of plane of symmetry is present. Plane of symmetry is present, my dear student. Plane of symmetry is present. So meso. Now if you see the trans alkene and Bayer's reagent, Bayer's will do syn addition. Now fill in the blank. S R, tushar. So racemic mixture. Once again these two are enantiomeric pairs. Enantiomeric pairs. Now 99% got completed. Only one reaction is left. If you see to it, ozonolysis. The first one is your reductive ozonolysis. Reductive ozonolysis. So break the bond from here. You will get 2 moles of acetaldehyde. We have got 2 moles of acetaldehyde. But O3 water is oxidative ozonolysis. So that aldehyde will get converted into acid. If this would have been ketone, then no effect. Now if you react with O3 zinc and water, you whatever the product you are going to get, same product like oxidative ozonolysis you will get with KMnO4 acidic medium. If you apply KMnO4 in acidic medium, you will get same product. Or you do the reaction with K2 Cr2O7 acidic medium, then also you will get same product. This is known as oxidative ozonolysis. Oxidative. Now if you want to take a screenshot, now everything is written over here. Let me move aside. So those who really want to take a screenshot, just see each and everything is visible. Let me check it out. Yeah, so awesome. Wow, you can take it, the screenshot. Okay, just see. Each and everything is clearly visible to all of you, my dear students. Now, bye bye. Take care. Those who are new, just subscribe the channel, and how much you have liked it, do let me know in the comment section. I will come with such type of great mind maps for free of cost for you people's success. I want to see everyone, those who are hardworking, to become a doctor like God. Next to God is doctor only. I always hate those people those are just purchasing paper for 10 to 50 lakh rupees. I don't want those people should get entry into the government seat. I want your entry. Bye bye. Take care. This is your Baba H.S.P. MSc Gold Medalist, GATE, GRF, then MTech in 2004 from HBTI Kanpur, and number one ranked producer. Okay, bye bye. Take care. All the best to all of you kids.